Eratosthenes. Generating a small prime numbers. One simple way of calculating primes is to use the sieve of Eratosthenes. Write down all integers from 2 through x, second point, circle 2 marking it prime and cross out all other multiples of 2, third, repeatedly circle the smallest uncircled uncrossed number and cross out all its other multiples, fourth, when every number has been circled or crossed out, the circled numbers are the primes. So here we are on the greatest common divisor. The greatest common divisor of two integers m and n is the largest integer that divides them both. Like GCD of mn is equal to maximum of k divides m and k divides n. Euclid's algorithm to calculate the greatest common divisor of m and n for given values, where m is greater than equal to 0 and less than equal to n, uses the recurrence greatest common divisor of 0 and n equals n, greatest common divisor of m and n equals greatest common divisor of n mod m and m for m is greater than 0. So for example, greatest common divisor of 12 and 18 equals greatest common divisor of 6 and 12 equals greatest common divisor of 0, 6 is equal to 6. So this is simple. You can simply find the greatest common divisor by using the prime factors of 12 and 18, also for 6, 12, and have to check that the maximum value of the greatest common divisor, and here the GCD of 0 and 6 equals 6, the same as GCD of 12 and 18 equals 6, and same GCD of 6 and 12 equals 6, because any common divisor of m and n must also be common divisor of both m and the number, and here n mod m equals n minus the integral value of n by m. Here this symbol we have already discussed is the floor function, and it gives the integral values in terms of a smallest integer less than or equal to a. Same for the relative primality, two integers m and n are relatively prime, also known as co-prime, when their GCD m and n equals 1, like that is they have no common factor other than 1. So here we can find many co-primes by taking the concept as the GCD of two numbers must be equal to 1. For example, 14 and 15 are relatively prime despite the fact that neither one is a prime. 6 and 35 are relatively prime. 6 and 27 are not relatively prime because they are both divisible by 3. So here we can see that if we take a prime number and the other number like this, here 15 and 14 both are relatively prime, means both are co-prime of each other, because 14 and 15 have no any factor in common except 1. So here 14 and 15 are co-prime. Same here, 6 and 35 are also relatively prime, and same 6 and 27 are not relatively prime because they are both divisible by 3. This is an important concept as we shall see later.